Hey guys, Gary Campbell back here with part two of the Chinese router Acorn project. If you remember last time, we'd left off with doing the control replacement, which is incomplete. And this next section I'm looking to replace the drives with closed loop or hybrid steppers. So I had gotten to the point where the major components were in place and the board was drilled, a little bit of remodeling done, the Acorn board on it, but waiting for drives and motors to come in, I decided to jump back to the frame. The frame is a KL6090 Chinese online, and um, I don't like building systems with just standard stepper motors. Most of the stuff I do requires enough force and precision that having stepper motors with encoders, a hybrid system, or clear path or servos is what I would do. But the price of this machine doesn't really allow putting on high end servos. So what I decided to do was go to a new lead shine product that's out there, the CSD 1008 drive and the CSM 23445 motor, and they're an economical combination, I think, with the drive, the motor, and the encoder plus motor wirings from lead shine are under $300 for the combo. First thing I noticed was that the alignment boss on the original motors on the left was much smaller than the one on the right, where so I knew I was going to have to do a little bit of machining in a couple places to mount those motors or possibly make an adapter plate. So I took out to measuring up the machine, and this is a view after it was done because I didn't take any pictures with the raw frame on the bench. But even though that this number on the gantry showed that they were equidistant, uh, it was different than the number at the back of the gantry where the gantry or the X beam mounted in. So that caused me a little bit of concern. I also found that the gantry to the beam was out of square, as was from the rails to the Z mounting plate, or the Z slides, were not square with each other. Once I had disassembled the motor and the ball screw, I noticed that there were pretty substantial binds in the X as it slid across on the rails. During the disassembly, here are some of the precision shims that I found where the assembler had made an attempt to take and remove some of the binds out of it. They had used various sheet metal and copper shims to stick in a place here or there. Also, once disassembled, I noticed that the side plates, you can see that where this arrow shows they had actually taken a die grinder to it because the motor through hole was not centered on the motor mount bolts, so they had to remove some material to get the motor to fit in. That it's hard to see in this picture, but these mounting locations for the linear bearing blocks were actually scribed in and marked and drilled by hand. And if you put both plates on top of each other lining up the holes, there were enough discrepancies that I decided I was going to have to basically remill all of the parts to make myself happy with it. Other inspected items were that they were about 15 to 20 thousandths out of square on the ends of the gantry beam, that the paint on the machine surfaces of the X slide and the Z slide, where the bearings and ball screws mount, were sort of globbed up with paint. And when I had disassembled them, the bolts holding the X slide to the bearings had been left loose, and when they were tightened, the the X would hardly slide at all. So they had left the bolts loose into the linear bearings, most likely because of the um, globs of paint that were underneath the bearings. So I stripped the paint and put all those mating surfaces into my mill, indicated them in, and took a couple thousandths off of them to clean them up. Other thing, I had noticed that this plate was a little bit undersized, and it was off center. In other words, the center hole there was also off center on the mounting bolts, and they did not line up with the ball screw. So I determined I was going to have to make another one of those. So I was off to digitizing different parts that I'm getting and getting them so I could take it into the mill. Also, the finish on the spindle bracket was kind of really crappy, and it looked like it had been dipped. So, I decided that I was going to take that and do some finishing and just some cosmetic work on it also. So here's a quick picture of one of the setups where I'm remilling that motor, uh, the boss mounting hole and the center through hole, and it was actually about somewhere between, depending on the direction, 60 to 80 thousandths off center. But that milling and then being able to take and come through with counterbore drills and make sure that all the holes from one side piece to the other were the same. And I spent a half a day machining on the side plates and all of the other associated Z stuff. Also noticed on the frame that if you see in the upper right, they had ground on the top of the frame and the motor mount adapter that was in there, and that someone had either taken a drill bit or a die grinder or something and hogged out the lower right corner of the through hole for the motor, because the coupling was hitting on the case. So I had to take and center out where the ball screw was, and the motor had actually been mounted about almost 1/8 of an inch too low. So, but in order to raise the motor, I had to take and notch out the bottom side of the table T-tracks to get the motor high enough to match with the ball screw when the ball screw mount was shimmed even to match the fixed hole in the front. So all in all, there was a whole bunch of machining and adjusting and work that was done, and that gets me back on the table, and a couple other odds and ends things that I noticed. One, the Z slides nice now. You can see that's on the left. Excuse me, that's the X and Z were nice and real free working as it sits now. And on the right, you can see the new top plate that was made for the Z motor mount. Also on the Z slide, you can see 2 arrows. Are not shown yet because I didn't do them until after an initial assembly. I drilled 2 holes higher so that the spindle mount would go on and mount a little bit higher because I like the geometry better. So that got me almost 8 inches of spindle clearance. During the assembly, I did not recut the ends on the gantry beam, but as you can see here, the top right of one side and the bottom left or the other were shimmed with 15,000 shims, and ended up putting 7,500 shims in the middle of them. So after another bunch of trial and error and indicating and getting things back together, we're back on the bench together, spindle mounted, wire run through the E-chains and out through the conduit that goes up into the motor. And a little quick peek, you can see in this one I've got it assembled and pushed over by my electronic bench, and if you look right through the E-chain, you can see that the control box is sitting there behind it, and that will be our next part of the project. So note so far on this that many of the parts are machined by hand and are not precise. Machined areas are painted over prior to assembly, causing alignment issues. Many of the cuts are not square. The build is not orthogonal. These machines are a good place to start, but if you want precision, you must do the work and qualify and get everything in and start, basically start back on the bottom. Luckily, the frame was stout, square, the milling was parallel, and there were no issues or dimension changes during that. If that would have been a place, my mill is not big enough to have remachined that cast iron frame, so I would have had to send it out to another machine shop. By the way, in a small note, that this seems extreme, but in my case, personally, with just the machines that I've owned, I have owned multiple U.S. built machines that were the same or worse than this. They were larger size. So the error was larger. The angular errors may or may not have been that much difference. But the reality is that anything you buy or build, you will have to check every part that goes in and make sure that it is square, perpendicular, orthogonal, and true, or we won't be able to acquire anywhere near the accuracy that we like to brag about on these machines. And so here's over to the control box that's on the bench, the drives, motors, wiring, and everything installed, and I'm saving the explanation on all of those for part 3. Thanks for watching.